Hey, Jody here. Today we're doing some lap joints using 6013 rod. You can find some awesome looking pipe welds done over in the UK using 6013. I hear it's popular over there for pipe welding. It's not here in the States, so I've just kind of like ignored this rod for forever, but trying to keep an open mind today. Help a student maybe get through this step so you can get on to 6010 and 7018. Or if you just got a buzz box and you want to build a wood rack or a welding cart out of square tubing, these tips should apply just as well. Let's dive in. I'm using an old school Thunderbolt today, set at roughly 110 amps, and I'm going to be on DC electrode negative. At first, we'll weld on all polarities before we're done. Bending the rod like this a little bit allows you to get pretty much any angle you want. I do it a lot. I'm welding right outside my back door on a little portable Nomad welding table. You can hear that Miller Thunderbolt groaning in the background, and I've got it actually muted for part of this because it's just hard to talk over. But I've got the amperage dialed in fairly close, about 110 amps. And the material is only 1/8 of an inch, 3.2 millimeters thick, so it just doesn't take a whole lot. I can see right now the thing's starting to bow a little bit. I'm going to have to put a few more tacks on it. Probably should have realized that to start with, but I'm going to put a few tacks here midway, trying to make them a little smaller than the final weld so I can go over them without seeing them. A good tip there would be to use a little smaller rod for those tacks, but I didn't have one on hand. I'm going to alternate directions here too. Every time I go from right to left, the next weld is going to be from left to right. I think it's good practice to go both directions early on in your training. You will have to do that in the real world, in the field. You're just kind of, there are obstacles in the way that require you to go one direction 1 minute and the next direction the next. Now we will be dunking this in a bucket, a quench bucket, periodically. I just got to say that's not something you want to get in the habit of doing to actual serviceable parts, but it's just for the sake of speeding up the process here. Oh look, got a little visitor here. Let's see if he's moving. Yep, we'll have to get him out of there right soon. I don't want to boil him. That water gets pretty hot after dunking it 4 or 5 times. Okay, so that one was right to left. Next up, we're going left to right. I get comfortable where I can make a full run without getting in a jam, and light up and go. See, everything just kind of looks different too when you change directions, so you need to get accustomed to moving your head, getting the right line of sight, getting comfortable. Left to right, right to left shouldn't make a difference after a while. Come to the very end, I'm backing up just momentarily to fill the crater. Good practice to get into. Now we'll quench it again. Alright, let's finish this thing up. Again, nice tight arc with maybe a good 25 degrees of rod angle, maybe 30. Finally got the heat kind of dialed in. I started off with some practice runs. I was a little hot, I was a little cold, but now, you know, it seemed to settle in about 110 amps. If this was thicker, if this was say 3/16 or a 1/4 inch thick, I could take the rod on up to the high end of the range, more like 125, 135 amps. But it's not. Just 1/8 of an inch thick. Doesn't take that much. See all that slag just swirling around in there and you can't really distinguish the puddle yet. That's kind of what I don't like about 6013s. That one happened to turn out good, but I've also been surprised and had slag pockets there on the start. Alright, we'll do a restart here. I'm going to light up ahead, long arc it just for about a second as I go into the crater, and then carry on. And hopefully I got right into the crater and there won't be any little void or anything like that. But I missed it by that much. Nothing like hearing a buzz box with birds singing. This is the first side of the plate where I was kind of dialing in the amperage, and I got surprised a couple times by like a little slag pocket like this, so I had to crank the amps up a little bit. But that's kind of the nature of the beast with 6013, especially if you're going slightly downhill. All right, now let's compare DCEN, DCEP, and AC. First up, DCEN. We're going to do a quick little run here, even though we already have run. I just want to refresh your memory with a good little close-up arc shot. Let's go to DCEP now. This is supposed to give you deeper penetration. And you can see it looks a little hotter, at least I think it does. Puddle seems to be a little wider, but not like night and day. And now AC. They all look the same, don't they? They sound a little different, maybe not on the film here, but in my ear when I was doing them, you can tell a little difference in the buzz of the arc. But you know, the rod's designed for all three, and they're really hard to tell them apart. There's the DCEP penetration, not nearly as deep as I would have thought. There's the DCEN, slightly shallower, but not much difference. There's the AC. Some subtle differences, but not like night and day.
What was really surprising to me was this was only 1/8 of an inch thick material, and I didn't even penetrate nearly halfway through. You just don't get a lot of penetration with 6013. So what are the takeaways from this video? Number one, make sure you have enough amperage, because what I see a lot of times in new students is, you know, not using enough amperage, like being afraid of it a little bit, and then having to hold a long arc to compensate to not stick the rod because you don't have enough amperage. Here's really good advice for any stick welding. You know, set the amperage hot enough where the rod won't stick when you hold a really tight arc, then hold a really tight arc. Another thing on 6013s is it's a very slaggy rod. That slag can swirl around and fool you, and you think you got a puddle, but actually you just got a puddle on each side of the bead and a slag run down the middle. So a little more rod angle than what the textbooks call for, which is they only usually call for about 10 degrees. I'd say 20, maybe even 30 degrees sometimes, to keep that slag pushed to the back of the puddle where it can't get up ahead of you and swirl and cause pockets and problems and all that stuff. Use enough amperage, keep a good tight arc, use more rod angle than what the books call for. You should get through that exercise, or you should be able to build your wood rack or your welding cart or whatever, no problem. And also, don't hesitate to use alternating current. You avoid arc blow that you get sometimes on DC, and there's not much difference in the results. So I actually, if I'm going to weld a 6013, I kind of prefer AC, but that's just me.